webinar, this second part, the Milton webinar, Milton 2016, we will continue to show you improvements and developments. And particularly for this webinar, is how we can change the machine for a programmed part. So we can move a part from one machine to another very easily. And another subject is how to work with a 6-axis machine. Those are the subjects for today. And I will start with a simple part in only a few operations. And this part is programmed on the Haas milling machine, 3-axis, with 4th-axis mounted on the table. So our coordinate system is oriented in this way with Z up, X and Y. So let's try to see in the machine setup. This is the machine, 3-axis machine with 4th-axis mounted on the table. This is how the part is mounted. Z-axis vertical, X, 4th-axis around X, and we will try to move this part to a 5-axis machine and see how we do it today. Because in the previous versions, when you move a part from one kinematic to another on a 5-axis machine, we need to position the part like this, and to change the coordinate system, edit the coordinate system to orient with Z as the center of this cylinder, the rotation. So when you change the coordinate system, operations were broken, geometry, sometimes you need to select again. In a few words, you need almost to get to edit all operations in order to make this part working. Let's see how it works today. So I have only a few operations, a profile on this face, just to demonstrate you, and on 180 degrees here a small slot, and drills, drill on face here and drill around 4th-axis. Now let's try to simulate this part in machine simulation, just to see, to understand the kinematic of this machine better. We can see all the machine. You already know this machine, and it's the first phase, second 180 degrees, drills, and that's all. Very simple, very fast. Now let's try to save this part as a copy. Let's call it _1. And change the machine. We will change the machine to a Haas UMC 750. It's a 5-axis simultaneous. For now, everything is okay here. I just need to calculate again. And in setup, we can see the different kinematic. Move the different kinematic with the table, 5-axis table, and the part is mounted in a wrong position, not as we want to see it. So what we can do in this case? Very simple. First, we create a new coordinate system. We don't touch, we don't edit anything. In the previous part, we work with Mach 1 position 1. We will continue to work with Mach 1 position 1. But only to mount the part, we'll create another coordinate system. So I have Mach 3 position 1, and it's center of revolution phase. I approve. Now we have another coordinate system which is oriented like this for this machine. I will use this coordinate system in the setup to position the part. That's all that I need to do. On the table, mount this part related to Mach 3 position 1, and the shift will be different. 0, x0, y0, and z150. Oh, I use it. Let's try to see now the mounting, how the part is mounted. Now the part is mounted in the position that I need on this machine. Nothing in change, no change in operations, no change in geometries, no change in any place. I just generate the G code and send it to the new machine. The only thing that I need to do is to reposition the part in the setup. And if we go to simulate, this part will work as previous. Now is using the B-axis, tilting of B-axis to bring it to 90 degrees, and work 4-axis as in previous machine. First operation, and the second, and the slot, drill, and drill around 4-axis. You already can see the progress moving parts from one machine to another. But I will show you another example. So I'm going to open demo 2, number 2. And here I will use a machine, a 6-axis machine with 2 rotary axes on the head, A and C, another rotary axis on the table, B. This table also can move. Okay. And for this part I create a turning operation and drilling on this face and another drilling on this face. I will change the setup because I want to rotate the part on the same table on this machine. I don't have 2 tables, so I'm using setup and not part transfer. Setup to rotate the part and continue to work on the opposite side. I will I create only a simple turning operation on the opposite side. And let's try to talk a little bit about I will try to explain you the complexity of this machine, but for this I want to show you the entire machine in machine simulation. This is the machine that we talk, and it's a vertical milling machine with turning capabilities. That means the table can rotate and we can turn on this machine. But And the next option is I can work 5 axes simultaneous on this machine with different axes. When we work 5 axes, we select 3 linear axes. We can control in operation 3 linear axes and 2 rotary axes. Now, if I create several submachines, I can select on one submachine, use A and C axis on the head A and the rotary on C. So I will work in kinematic head. In other submachine, I can choose work with A and B, the rotary axis on the table. So I have 3 submachines on this machine. One submachine is for turning. The second submachine, 5 axis, milling 5 axis A and C. Third submachine is milling 5 axis A and B. Now, each time I will select a combination of 2 rotary axes. One axis remain uncontrolled by the operation, but we can still control this axis with machine control, with our MCO. So, in first operation is a turning. Third operation is a drilling on this face. But let's try, here I have an MCO, and I will suppress now to demonstrate you why we need it after that. First, we need to see the situation, the case on this machine. Let's try to simulate only 2 operations. And the machine control between is suppressed for now. So we can turn, as I already said before, we can turn on this machine. It's a simple finish operation. And next operation is drilling here on this face. But in order to get to bring the tool perpendicular to this face here and to drill, I select milling A and C. That means axis on the head. And that's what it's happened. Bring the axis, machine simulation, bring the axis exactly with the tool in the correct position, but they are out of limits, and we can have a collision. It's not a good case. We cannot really machine this part on this angle. So what we do, we remember that this rotary axis on the table, the axis B, is still in our control. So I will control it with MCO. We'll unsuppress now. And in MCO, I will rotate the table minus 100 degrees. And now the operation is recalculated. And let's see the result. First operation turning. Now machine control will rotate the part. And now this is the new case. In this way, in this position, I can work. I don't have any collision, and the axis, all the axes are in the machine range, in the limits. Next operation is again drilling on this face, but I select another kinematic. I select kinematic milling with A and B. When I work with A and B, now I have to control axis C, which is remain uncontrolled by operation. So here in this MCO, I will send C-axis to reference position, 0 degrees. Let's try to simulate all of them. Again, the turning operation, now MCO rotate -100, drilling, and I reset, send the C-axis to 0 position. And now I will use only A and B. B is controlled by operation. You get an angle of -50.78, and I can also work. So on a 6-axis machine, we have 5 axes controlled by operation, sorry, and the 6th axis is controlled by user in machine control. Setup, second setup, the part is rotated and we have here only a turning operation. That's all. Now let's try to move this part to another machine. We have here different kinematics, different sub-machines using MCO, the second setup. What's happened if I move this part to a standard mill-turn machine, like a horizontal, like a Okuma or Integrex with 2 tables? So I will select here, let's first copy this part and see what's happened. _1 and change the machine. I select, I have a new machine in the collection, Multus U3000, and this window pop up, and here the user is asked how to convert operations done by a specific sub-machine on previous machine to a sub-machine on the new machine. And here I can choose operations that we done with turning sub-machine in the previous. I can select working on upper turret main spindle or upper turret back spindle on this Okuma. I have 2 sub-machines to select here. For now, I move all the operations to upper turret main spindle. And calculate. Now, let's start thinking. This is, okay, let me show you the machine. It's a standard horizontal mill-turn machine with B-axis and 2 tables. Now I don't have here 6 axes. Not on first sub-machine upper turret main spindle and not on upper turret back spindle. I don't have 6 axes. So this machine control is not necessary here. I don't need to control anything. I don't have any uncontrolled axes. I will suppress them or I can delete them, anything that I want. For now, let's just suppress them. For turning operation, I don't need to do anything. The coordinate system with oriented like this is okay. The setup is okay. I don't have to change anything. The MCO I suppress. Now, the second setup, I don't need it. I can transfer the part to the back spindle on this machine and continue to work, so I don't need another setup. Let's delete it. We'll delete the setup. Now I want to transfer the part to the back spindle. For now, this part is done by upper turret main spindle. Let's change to upper turret back spindle. save and calculate, and we get the message. The stock is absent on selected submachines table. That means I create an operation, I create a toolpath, and I select everything correct, the coordinate system, the geometry, orientation, but I don't have a stock on back spindle. I didn't transfer the part from the main spindle to the back spindle. Let's transfer. First, in the setup, I will define that on back spindle we work with Mach 2 position 1. And here I need to position the part out of the spindle. 540 millimeter is the length of this part. I just put it out of the spindle, the full length. And after this operation, I will create an MCO. CNC operator for now. In the previous webinar, you already see how to transfer a part for one spindle to another with all the process, moving the back spindle, unclamp, clamp the part, release from the main spindle, retract, and all the cycle. Now I will use CNC operator, manual stock transfer, where? To back spindle. Save and calculate. Now the operation don't have a red dot. The operation is correct. I have a stock on back spindle, and I can work. You can see the toolpath. So what we did here, we removed the MCO because I don't need them. I changed the submachine on the last operation, working with another table, and create a new MCO to transfer the part and delete the previous setup. I think it's very simple to do this. More simple than in the previous versions where we work hard, but it was very difficult to move a part from one kinematic to another. So we can start showing the toolpath. This is the turning, and oops, what's happened here? Now you know, in 5-axis you have angle pair. This angle pair selection, the first angle pair or other angle pair, can be different from one machine to another. On one machine I prefer second angle pair, the other angle pair. On the other machine I prefer the first angle pair. So this is also something that we need to check in the operations, technology, motion control, first angle pair. In the previous machine, second angle pair was our default selection. Exit. Let's check also the second drill. First angle pair. Okay. Different submachines, different drill, each one of them with a different angle pair. So if we try again, it should be okay. Turning and milling with the correct angle pair. And the second angle. Moving the part to the second spindle and finishing with the simple turning operation. So it also, we see in the first part, moving and milling a part from 4-axis to 5-axis, and here mill turn part from one machine to another, a vertical mill turn machine to a horizontal mill turn machine. It's also very easy. The next example is to show you how we can handle today multiple coordinate system. Open demo 3. For this part, I will machine this part on the previous machine that you see, the mill turn, the vertical mill turn machine. And on this machine, I can do turning operations here on this side, because the part is rotating around the z-axis. Axis B of the table you can rotate. So I will select the turning operation to remove the material from this face and inside the feature. And for this side and the opposite side, I will use milling and working with different sub-machines. Once I will work with AC and once I will work with AB. I will combine the operations with different sub-machines and let's see how to handle it. But you already know that for 5-axis in the axial part working on different faces, we create positions. But today you can work also with a new coordinate system, with a new MAC. This option was also available in 2015 and have a different name and a different interface. We know them as related MAC. But today there is no related, there is no one parent MAC. It's just defining the coordinate system with any number of coordinate systems that you need and just use them. Yes, they disappear from setup. If you work with this, you know that in the setup you have here another field, another window with additional or related MACs. Today they are all available to use with no difference, and each one of the coordinate system that we create can be selected to position the part. So okay, I show you we have a coordinate system here on this face, on this center of the cylinder, and Mach 2 position 1 on this face, Mach 3 position 1 here on this face. I will start with the turning operation. Remove the material, all the rest material from inside, here on this step and on the face. I will define a face milling on a spiral face milling to remove all the material that we have here, rest material, and a profile to reach this depth, and the drill. Now the save operation, I copy the operations and select another submachine. Here I work with A and C, here I work with A and B. Between them, what I need to do, C-axis remain uncontrolled. I need to reset the C-axis with NCO in order to continue to work with A and B. The same for the opposite side. The same operations, a face mill, contour, and the drill, starting with A and C, kinematic, resetting, sending the C-axis to 0, and continuing with submachine with A and B, head table, kinematic. Let's see how it's working. waiting for simulation to prepare the STLs and all the needed data. This is a big part, a very big part. It is a 500 millimeter diameter and something like a meter length. Okay. Now I want to see also the stock. Now, this is the stock. This is a revolve stock. When I'm in an operation, in a turning operation, the part is rotating, the stock is rotating, and it creates this form. And is very useful to detect collisions. My toolpath is here. And now milling operation. Now let's set this message and jump again to second operation. Now working with A and C, the table is not rotating, the B axis is on 0 degrees, B is rotary axis of table, and in order to reach this position, to bring the tool perpendicular to this face, we use A and C. And the contour and the drill. Now the same operation, working with A and B, I will retract the turret, reset the C axis, and now B axis will move, will rotate, using, I use A and B axis with the same operations. Contour and drill. Retract again. B axis to 0 degrees. Work on the opposite side. Mach 3 position 1. In with exactly the same technology. A and C, face, contour, and drill. Now why I show you all this? Because on the machine, the part can be mounted in a different position. The form, the shape of the part can be in this way that we will get, working on some faces of the part, we will get very weird angles. So the user always can choose the best case, working with A and C, working with A and B, with different sub-machines. The user can select the best case and the case where the toolpath is in the machine limits. That's what is important. And contour and drill, that's the last operation. That's how we handle a 6-axis machine today. 5 axes are controlled by the operation, 6 axes controlled by us in MCO, and we always have the possibility to choose what is best for us. That's all for today. This was a continue of the previous webinar. This is what we prepare for today, moving the part from one machine to another with different kinematics and using multiple coordinate system. If we have questions, Eddie, I cannot see the
Yeah, Florin, first of all, thank you for the webinar, and we have repeated requests to share with resellers the parts and the files you used during the webinars. So this is the first, and not first, many questions like this we have. And we have also a few questions about the webinar itself. So the first question, I think that it would be very useful if we could change the angle pair for several or for all operations. What do you think?
Yeah, it's an option that we already think about this. It's still in the development team. We need to research and see how it affects all the operation, and we know about it. We already heard about this request, and we think about this. Yes.
Okay. The next question. This new system of work with Max is great. If you have a time, could you show us how it works in the GPP?
For this machine, I don't prepare a post here because on the webinar I don't use G-code, but it should appear like a new coordinate system. Every time that you have a new operation in the GPP, you get the rotate to plane, and there you have number of Mach that is used. So you changing number of Mach in the G-code, you should get the new home number, G54, G55, G56. In Fanuc, for example, or other controllers, you have a different format. But nothing different than how you work in a previous way, in a previous part, a 3-axis machine, a part, and you work with one coordinate system from the upper side of the part. You continue to work with second coordinate system, Mach 2, position 1, on a lower side of the part. And you get 2 different coordinate systems in the G-code. Nothing, we didn't change in the G-code anything. Also in the previous versions, you get Mach number when you change it. The problem was only in 5-axis indexial that we need to select, in order to calculate the angles, we need to work with positions. Yes, but if you work with a new coordinate system, the angle always will be 0, because this coordinate system in the work offset table on the controller have the angles already inputted there in the work offset. So you work with Mach 3 position 1, you select G56, A, MC, A0, C0, and you get the position. So now in the GPP there is nothing new to support this. It was only internal calculations in SolidCAM code.
Okay, Florin, next question. Is it possible to move the part from a milling machine to a turning machine with updated stock?
Milling machine to a turning, no. Milling to turning, no. If you move a mill turn to a mill turn, but not a milling to turning, you cannot change a milling part to a turning machine, because in a turning machine you don't have milling, so what you do with all the milling operation? So it's
maybe he means mill turn machine, from milling machine to mill turn machine.
Okay, so with updated stock, everything that you have here in the tree that you define is going to the new machine. Also, the defined stock, the defined target, everything. Nothing loose on the way.
Okay, Florin, clear. Okay, guys, if you have any questions, so please ask. This is the last chance now. I mean, through the webinar, of course, later you are invited to ask all questions you have also. And again, we receive the questions about the sample files. So you will find it either on our reseller forum or on a reseller area in our website, new website. So for meanwhile, I would like to thanks to Florin for this interesting webinar, and to thanks to all our resellers. Many of you joined today also. Thank you very much, and we wish you successful sales at the end of the year. And we are here, all our staff, to support you in all you need. Thank you very much, and have a nice weekend.
Thank you. Bye-bye.